Let's start that streaming.
Oh, in meters.
I'm looking at everybody walking around. I'm looking at the sheets. But then you were looking at me, so then I was looking at you, looking at me. Oh, thank you. Oh, terrible. It should never be out of number. Yet not in class. You're waiting for an email that you're going to check after. Put it in your bag. Yeah, I know. Put it in your bag. Slide it in sideways. You can start that right. So most people see movies down the first part. What? No, it's very rarely like that. They often don't like that, in fact. Caden, what are the units of mass? Kilogram. Excellent, well done. Julian Chan.
Yeah.
G is the
gravity.
No.
Force. Oh, no.
It's the something of gravity. It's not a force.
The measurement. I don't know. It's just a meters per second. Meters per second squared.
It is a meters per second squared, so you got one. But what is a meters per second squared? Riley, what's a meters per second squared?
What is meters per second squared?
Yeah, G is the, what is that? It's not a force. What is it?
It's like the equation.
Well, it's a meter per second. You could give me the value. What is it always on planet Earth? Pardon?
9.81.
9.81 meters per second squared, which is not a force. A kilogram meters per second squared would be a force. That'd be a Newton. Anders,
Yep.
what is G? Can you fill that in?
G is the value of gravity, right? It's gravity.
Yeah, but what is it?
It's gravity, no?
Yeah. Well, that word is up there. I already know that. What is gravity? We already established it's not a force. So what is it? You could then go to this one. What is H?
Height.
Height. Perfect. When I ask someone, I do not need a course. Allow them to do it, please.
Ooh,
Wait, not you. Mirhat? Pardon? What are the units of height? Or you can tell me what G is. There you are. It's not direction. Attraction implies a force, so I'm going to say, no, you're actually in a weird way kind of closer, though. What are the units of height? Excellent. Again, if I have asked someone, please do them the respect of allowing them to have a chance. Vienna, what is G? Acceleration. You gotta have confidence.
I choked.
Confidence is key. Even if you're wrong, confidence is key. If you're confident, you can be a president. Potential energy. Oh, I just said it. PE is the potential energy. Oliver, what are the units of potential energy? Joules. And what are the actual SI units within joules? Yep. Yeah. And so when you're doing a calculation, you can convert joules back into that and then start canceling your units. We already wrote it up above. On your sheet, I don't know why I have this there twice. Potential energy changes linearly with the height of the object. So an object with, there's a lot of different ways you can write that. What did you go with, Esther?
The high.
The height has how much potential energy?
How much?
Yeah.
I just write bigger.
Bigger the potential energy? I mean, this kind of works. I mean, it's true, but it's missing a little bit of the relationship. We could put numbers into higher. How much higher?
Oh, how much higher?
Yeah. Twice as high, 3 times as high, 5 times as high. What do you want?
Oh, I can decide. What?
Yeah,
Okay, 5 times.
5 times. So 5 times the height has how much potential energy?
But, how much?
Yeah.
Then it's
Would it be, if it's 5 times the height,
5 mGA.
yeah, it would have 5 times the potential energy. We just did the piano, it had twice the potential energy. And if we were to go smaller, I was to say, for example, to Mick, if we have half the height, what does that do to the energy? Half the energy. Yeah. Ooh, H55. That's enough. On your way out, don't do that. I'm going to put these right here. Grab one, meet me at the physics table.
Pablo's partner. What did we say? I'm so sorry.
You so much. Would you? Yes, I think you really trying to.
Hey, we were trying. It's just, you gotta focus. We can't be having the facial expressions.
I didn't notice that the numbers moved.
Please.
So, your hypothesis,
We're doing a lot. And I'm actually with Nick. Me and Nick. So funny. Write your hypothesis, Judy. Yeah. It is. So just. Yeah.
so the diagram on your sheet, the 1 and 2 left. So just to clarify, 1 is the very beginning, 2 is the very end. How the mechanical energy at the beginning compared to the mechanical energy at the end. Mechanical energy is just the kinetic plus the potential. So it's the total energy of the system. And how will the total energy of the system be at the beginning and the end? Write out your hypothesis, bring it out, and then you can get started once you've shown it to me and I've signed off on it. I'm going to put my track away.
Gigi, do you have the worksheet? Do you have the worksheet?
My apologies, my apologies.
I'll say this. This is what I read. It was Gene Steve. It says this is frictionless incline archetype. So, not even if it's frictionless, then it's going to constantly gain speed.
Which is mechanical energy at the start and the end of the thing. Here's makes sense.
Why is that?
There's potential energy at the start, but no kinetic. There's kinetic energy at the end, but no potential.
Yeah. Just look at N the order of the carbon.
And is the stop.
Oh, okay. NB. So,
They don't give them a hypothesis or something.
so you'd say
Mechanical energy will be the same. Wait, Jules. Let's guess.
The hypothesis. It'll stay the same because at the start there's potential energy but no kinetic energy. But at the bottom there's kinetic energy with no potential. I think it's just
Someone left their copies out there? I'm assuming they were extras, but I'm missing the copies right here.
Can we have one of the, can I have one of the extra ones?
Pardon?